Uh, Now, this is for the panelists as well as the audience here to judge. What kind of technologies would we call artificial intelligence? Is this the most primitive technology? A wheel? Is this AI? I guess not. No one would call this AI. A train, a steam engine? Maybe not. A bulb, a washing machine? Is this AI? It has lots of buttons and lights and modes and functions. Is this AI? Is it a microwave? To some extent, maybe. A self-operated tap? No. Yes. A phone? Definitely. A self-driving car? Yes. Okay. A robot? Fine. And yours truly? I mean, where does one draw the line? So, to explain what do we mean by AI, I'll invite Rahim sir. It all feels like magic. This last decade, last 10 years has felt like we're living in a surreal world. And every day something new is happening. Someone more is claiming intellectual rights to our own human capabilities. So what's going on, sir?
See, if I have to put it in very simple words, artificial intelligence is basically ability of a system, maybe a computer, a software, a machine, to emulate human intelligence. So what do we mean by that? We mean the cognitive functions of the human brain. The classical examples are decision making, classification, or judgment. So there are two aspects to it when we call it as intelligence. How deep is it and how broad is it? So when we say I have a expertise or my cognitive ability is good, then I say I have a narrow intelligence. So traditionally, when we started, like if we go back to the previous slide, most of the from the half onwards, they have some kind of intelligence. If I have to go back to the example of say washing machine, so they have what is something called as fuzzy logic. So where the system automatically sort of tries to calculate how much is the weight, so it automatically adjusts how long it should run the spin, and automatically adjusts if the balance is not correctly, it automatically try and correct it. So this is what you can call the earliest forms of AI systems we have seen. They are very narrow and the depth is also very shallow. So as the systems have evolved, people have figured out how to improve the depth of the systems. So now when we hear that a AI system or a AI tool is able to match the accuracy of a radiologist in diagnosing pneumonia on an X-ray, that means it's a very narrow AI. That means the depth it has achieved. That means it was able to achieve the depth of a human being. But the system will not be able to do anything else apart from the task. So that is what when we mean by a narrow intelligence. So once we achieve a significant amount of depth, then we started going into increasing the breadth of the AI systems. So that's where we trying to achieve what we call as AGI or artificial general intelligence, where a single system is able to do multiple tasks. So from the classification point of view, we can broadly divide them into say supervised, that means where we have a labeled data set and the system learns from it, or unsupervised, that means we really don't know what is the ground truth, the system we ask to find out itself, or what we call as reinforcement learning. Some classical example is autonomous cars, or in our healthcare practice, since what we are hearing since morning, the robotic surgeries, where the system is able to achieve a complex series of tasks to achieve the ultimate goal of a good surgical outcome based on what we call as a state and as well as the reward oblique punishment which it gets at each steps. So another buzzword is like deep learning. So deep learning is basically the machine learning systems or artificial intelligence which use artificial neural networks. For the paucity of time, I'll not go into how a artificial neural network works, But if I have to tell you in a one single sentence, what does deep learning means? Means this is a end-to-end AI. That means the traditional computer-aided detection models which we used to have, or the older generation of AI models, where human beings or the doctors used to define the features. That means if I have to say diagnose a wax in a ear using otoscope, so you have to tell that the wax consistency will be this thing. What are the things the system should look for to identify that it's a wax, right? But in the deep learning systems, it's an end-to-end. You just show a picture of wax and you ask the system to figure out how to diagnose that is wax or not. So that is how a deep learning system works. So what is the flip side of it is, now since we are not telling how to learn to diagnose wax, it can pick up anything. It can just say that malab, if a person is coming from a low socioeconomic status, then he might be something like that. So it might figure out its own thing, which may not be actually true in a logical sense. The last 1 year, we have been seeing a lot of discussion about generative AI. That means where the systems are able to generate new data. Why it is important, especially for healthcare? The problem for healthcare is because we don't have enough data. I can't say that I want 1 lakh images of, say, cholecystoma. So that's where these GAN-based, GPT-based diffusion models come into application. So applications, regression models, classification models, natural language processing tasks, where we come up with AI assistants for pattern recognition, predictive analytics, precision medicine, and AI agents and AI enhanced diagnostics. That's what I feel how AI relates to in healthcare.
So, if I may paraphrase, sir, like we have members of all three services here on stage. Now, if I tell AI model to, I just give a general equation that uh, blue is Air Force, olive green is Army, and white is Navy. Would you call that supervised learning?
Can you?
I just give an algorithm, a formula
Mhm.
that olive green is Army, blue is Air Force, white is Navy. So is this supervised learning?
Yeah, in a sense, you can say. But the thing is, like, what you're saying is, you're not telling why it is Army, why it is Air Force, right? You're just giving a label data.
Yeah, the why part, so obviously, even the most advanced models don't know why. But for a starter, we can keep this as a kind of a supervised learning. And whereas if I don't mention that, if I just ask an AI model to take a photo of the stage and identify at least 3 different kind of people, would it be able to do that?
Yeah, unsupervised learning can try.
So that is unsupervised
That's what
learning. Then.
unsupervised.
So even if you don't label them as this and that, it can still gather meaning out of just looking at clustering of people or objects or data points in a given space. So that is, I think, the key difference between supervised and unsupervised learning. So moving on to the ENT surgeon's perspective. So Colonel D.K. Gupta, sir. So when we talk about application of AI, or this forum is about AI, but most of the techniques that we've seen throughout this morning were not AI. They were assistive techniques to surgeons. To some extent, they augment the facilities of the surgeon, but where does that augmentation end and where does it begin? Where do you see AI going or making an advent in surgical procedures, sir?
So, since morning we have heard various talks about the robotic surgeries and their limitations as well as their advantages. So, presently the robotic surgery is based on the master-slave model. When we talk about the autonomy, so that autonomy is a thing which may take these aspects of robotic surgery to the next level. Maybe I can give you an example like if there is a situation when there is a spacecraft and there's a medical emergency and a robot is able to perform an emergency tracheostomy, maybe because for the angioedema. That is the ultimate level of autonomy which we want to achieve. However, there are various levels like level 0, where we are right now presently, like an open surgery where everything is done by the human. When level 1 autonomy, when there is some assistance in terms of image enhancement, or then level 2. Level 3 is level 3 autonomy is when some more functions can be achieved by the artificial AI per se, various algorithms. So when we talk about the utilization of robotic surgery with AI, like in there are various algorithms which have been developed and not presently in vogue, but there are they can identify the lesion per se, whether it is a cancerous lesion or it is a native tissue. The surgical planes can be identified using various algorithms. So I think.
Sir, so this is a question which I'll like to ask all panelists, as well as seek opinion from the audience at the end of this session, that supposing we carry on with the same model that we promulgated on the first slide, that I've trained a model to recognize the 3 services. Now, on a given day, if a naval officer wears his combat dress, how likely is a model to mistake his uniform as an Air Force? So, and what can we do about it? I'm putting it in the most simplest of terms so that we can have definite and basic answers.
You see, the unique thing about AI is that it is constantly evolving and learning.
Sir.
So this is the one set of data that we had given initially regarding the 3 uniforms. If over time further data is coming to the AI model and it is learning over it, most likely it will identify that combat pattern also being unique to some particular service, and it's likely it will be able to diagnose it correctly.
Sir. So
similarly,
yes,
like,
Yeah, I just like to add, giving the same example. Suppose I show a AI system, 100 sailors and 100 Air Force officers. So we presume that the system has learned to recognize a naval officer by the color of the uniform. For all we know, the system might have figured out that this set of people who have beard in a uniform are they are naval people. So even if a naval officer is wearing, say, a pink color dress, which is not red, green, blue, the system already has picked up that place. So where it is not able to use the color of the uniform or the cloth which is wearing, it will look for the other, you can say, less important.
Yeah, maybe
features.
it was a Friday. I mean, there could be hidden variables in there.
Yeah. So that's what I said when we call it the deep learning models, or hidden models. We really don't know what the system is looking at and how it is figuring out. So that is the beauty of the systems, and that is the fallacy of the system also.
So how much autonomy can we give them? I mean, the basic question which comes, because techniques will keep evolving, surgical techniques will come, new AI models will come, machines will come, but how long can and will the surgeon hold on to his grasp and control? So are there any situations that any of the panelists who have faced in real life such a scenario using any such advanced tools or surgical techniques, sir?
See, I don't think so. We have reached a stage where we can give level 5 autonomy to the robotic surgeries. At the max, what we are seeing is in a very limited case scenarios, maybe level 3 is what we have reached. See, all over the world, healthcare is a high risk AI, where the stakes are very high for the if there is an error in, say, surgery. So the systems are not what you can call the human beings are not confident enough, or the systems have not evolved enough to go beyond level 3 autonomy at this point of time.
Sure.
So the challenges are not just the computing power of the robotic systems. It is a latency, like one of the speakers has pointed in the morning. When we are working, trying to use robotics in a surgical field, in an ENT, we want real-time decision making, where seconds may be difference. So that is one problem. Second is implementability. That means we don't want a system which costs crores rupees, for doing a simple surgery like a mastectomy. So we should be simple enough to be used in a routine practice. It should be, the cost should be slow